spot the mistake in this proof. We know this is the limit definition of E, Euler's number. But where does it come from? Let's prove it, or claim to prove it. Assuming this limit exists, let's call it y. And now we'll take the natural log of both sides. Already you may be thinking, wait, this is circular reasoning. You know E is the answer, so you're using the natural log, its cousin. Well, that's not actually the case. The reason we use the log here is because we have a power of x. And whenever we have a variable in a power, the natural log, or any log for that matter, helps a lot because the power comes down as a factor according to one of the properties of logs, and that'll make things much easier. Let's have a look. The limit inside has the form 1 to the power of infinity, which is an indeterminate form, but what matters here is that this must be a positive number, and so the natural log is continuous there, meaning we can swap the natural log and the limit operators, like this. And now we'll invoke the logarithm property of bringing down the power as a factor. This is a case of infinity times 0, so to make it compatible with L'Hopital's rule, we'll bring the x to the denominator as 1 over x, like this. And now this becomes a 0 over 0 situation, allowing us to use L'Hopital's rule. We'll take the derivative of the numerator and denominator. For the natural log, it's just 1 over the argument, and then we'll use the chain rule. Notice that the negative 1 over x squared cancels out, top and bottom, leaving us with this limit of 1 over 1 plus x. As x approaches infinity, this approaches 1 over 1 plus 0, which is 1. So the natural logarithm of y, the limit we set out to find, is 1, meaning that the limit itself is e. And that completes the proof. Or does it? Believe it or not, this proof is actually invalid. Can you find the mistake?